This may be one of the slowest custom wheels to get, not because one rim takes months to make, but because orders can wait 2 years. Once the molten aluminum meets the hydraulic mold, this piece becomes much more than a simple wheel rim. It is built for the track, a racing part made for speed. For this kind of rim, the factory starts with a strong aluminum alloy, sometimes blended with recycled castings. Custom work is not like mass production, and the first pass success rate is low. Take this one, for example. This steel frame is a mold used by the factory for 10 years. It is built from I-beams and hydraulic rods. First, workers spray the mold with release agent, helping the molten metal flow and cool more evenly, so the details come out cleaner. The worker on the left controls the hydraulic system. The inner mold drops down first, then the outer mold closes in slowly. By now, the aluminum is near 700 degrees. 2 workers nearby pour from both sides at the same time. This keeps the metal moving and reduces uneven cooling inside the mold. If only one side were poured, one area could harden too early. Before the mold is fully filled, after about 2 minutes, they open the valve and lift the rim out. But right here, the most delicate part begins. First, the workers set an iron mesh underneath. Then 2 men hammer in a steady rhythm. One bad strike can crack the casting. If it releases cleanly, the next steps become much easier. The newly cast rim is still extremely hot, so they use a tray and clamps to move it into the next workshop. Here, a specialist begins removing the rough edges. Large extra sections break away with a light tap, but the thicker connection points need a power saw. This depends on years of experience. Even then, the casting may still hide small defects. For example, the gap near the base may sit about 2 millimeters too high. That is where the second grinder comes in. It smooths the inner side of the rim, while the outer tire seat is finished by CNC machining. During this step, workers can spot many tiny flaws. Some can still be repaired with electric welding. To them, this is not unusual, and the repair can be nearly invisible. Look at the gap from earlier. It has been filled and built up by welding. After a second round of grinding, you would hardly know it was there. But not every rim can be saved. The pieces thrown into the furnace earlier were rejects that failed inspection. Besides pressure casting, this custom shop also uses sand casting. Inside this room are 2 sand piles kept year-round. Before each new job, workers dampen both piles with a watering can. Then they lock in another sand mold and place it over the larger set as the 2 sand sections line up. A clear gap remains in the middle. Different wheel shapes need different patterns. Next, the workers add sand around the outside, packing it tightly around the mold. The iron mesh helps control the aluminum overflow. Once everything is ready, the third mold is brought in. The worker hooks it carefully into place. Because it has a new structure, it is the key mold in this whole setup. So why do they wet the sand before casting? The sand must be packed down and stepped firmly into place. Only after the pattern is clear can casting begin. From start to finish, this casting work has already taken 2 hours, and in that time, they make only 8 pieces. That is one reason customers may wait so long for an order. According to the owner, global orders are backed up for 2 years. As the molten aluminum solidifies and the damp sand dries, the worker gets ready to break the mold open. Each sand mold is prepared fresh for the batch. What comes out is only a raw aluminum casting. Some are large rims for off-road vehicles, while others are much smaller. Once the extra metal is trimmed away, it begins to look like the pressure cast rim from earlier. Next comes the harder part, precision machining. The worker uses a wrench to secure the rim. Inside an automated CNC machine, this is one of the few CNC units in the shop. The right side tool and the left side cutting blade give the outer rim a polished finish, but 2 important steps remain before it is road ready. These steps affect high-speed stability, so a more experienced craftsman takes over. First, he centers the wheel on a steel plate, then moves it by hand under the drill press. 5 guide holes are already drilled in the plate. When the machine starts, the drill bit follows those guide holes. This is where skill matters. He must control the drilling speed, so the force does not crack the rim, while also watching the bit to prevent overheating. For more than 20 years, this factory has used this hands-on method. The output cannot match mass production, but each custom rim can be worth far more. Manual work is never perfect every time, so each rim still needs a careful inspection. The craftsman first places it inside a test chamber. When hydraulic pressure starts, rubber seals from above and below press against the rim, creating a sealed space in the center. If water leaks in or bubbles appear, the rim is not safe for the road. After treatment, the rim turns pale white, with a bright, almost mirror-like surface. The finish looks good, but bare aluminum would not last long in use. So 2 coating layers are applied. The first is a light white primer. The second is a darker outer coat. There is a reason for this. Ordinary paint does not always bond well. So the rim is placed in a custom iron box and heated at a steady temperature for 30 to 40 minutes. This method is common on automotive alloy parts. Most people know it as powder coating. Now the sanding, the surface feel, and the final appearance all show the work behind the piece. Next, we see the finished rim installed on a race car. Because this is a cast rim, the spokes appear wide and very solid. Forged rims, by comparison, can look slimmer. But casting offers customization. For stance and fitment, you can even choose the exact ET offset.